So, a fast way of graphing exponential functions dealing with transformations. Let's take a look here. So suppose you've got f of x equals 2 to the x plus 1. Well, let me back up one step and graph what I like to call the base function, okay? Notice these are all 2 raised to some kind of power here, okay? Well, in a previous video, we actually talked about this. So let me graph my base function real quick. If x is 0, y is 1, when x is 1, y is 2, and I got an asymptote coming off on to the left here on the x-axis. And for illustration purposes, let me call that one k of x, okay? So that's my k of x function. So I'm going to use that now and start transforming this. So what I like to say, if you've got action going on in your exponents like I've got here, it's going to move either to the left, to the right, or to the left. Okay? So it's kind of like the opposite of what you would think. Sometimes I like to say, okay, let me take this x plus 1 here and just say, let's make that equal to 0 and find out what x is. Okay, it's a negative 1. So yeah, it is kind of the opposite of what you would think here. Alright, so if it's x plus 1, that means this black graph here, this curve is going to shift 1 unit to the left. So this point at 0, 1 is going to be at negative 1, 1. This point at 1, 2 is going to be over here at 0, 2. And there's your curve. See how it's shifted to the left a little bit? And I'm going to call that f of x. As for my g of x, I'm calling that one 2 to the x minus 3. So guess which direction that's going to move? Yeah, to the right 3 units, right? So I'm going to take my black curve and I'm going to move it to the right 3 units. 1, 2, 3. This guy over to there. So there's that guy. That's my g of x. Well then, what happens if I've got some action going, but it's not in the exponent, it's off to the side here? Well, if I've got a plus 4 in this case, if I've got something getting added outside of what's getting raised to the power here, it's going to raise it up. In this case, it's going to move up 4 units. So my black graph here, it's going to move up 4 units. So here it goes up 1, 2, 3, 4. This point also moves up 4 units. Now, something else is going to change in this case. When we're talking going up and down, our asymptote is going to change. Remember, the original asymptote was on the x-axis. The minute I start adding or subtracting something outside of the original function here, that's going to affect your asymptote. And if you look at this number, that's what the asymptote is going to be. It's going to go up to 4. 1, 2, 3, 4. Here it is. Notice this curve will not cross that asymptote. So that's my h of x. Okay? Now there's a name for this asymptote too. I haven't been addressing that, but it's an equation. In this case, it's y equals 4. Okay? Don't just call the asymptote 4. 4 doesn't tell you anything. Okay? 4 is just a number. But if you say y equals 4, okay, now we're talking about a horizontal line crossing at 4 that this curve cannot cross. Okay, so make sure when you label your asymptote, you actually give it a name. Now let me do the j of x here. 2 to the x minus 5, guess where this one's going to go? Yeah, it's going to take the black curve and drop it down 5 units. And where's your asymptote what's your asymptote called? Y equals negative 5. If you said that, you are correct. 2, 3, 4, 5. So here's my new asymptote. Y equals negative 5. 2 to the x minus 5. So this guy here drops all the way down 5 units to here. This guy drops down 5 units to here. And there's your curve. So right now I've got a huge mess of 1, 2, 3, 4, 5 different equations, functions if you will, plotted on the same graph. I'm going to go ahead and shut this video off. And we're going to look at all these guys rolled into one. But first, we need to talk about reflection.